over to you, Nikita, who's going to talk about cloud transformations in memory computing. Thank you.
All right, Stephen, thanks a lot for the introduction. Good morning, everybody. Good afternoon, good evening, depending on where you're joining from. Just quickly, my name is Nikita Ivanov. I'm a founder and CTO of GridGain Systems, and as Stephen graciously mentioned, I was the one who put first lines of code for almost, actually over 10 years ago in a project what originally was GridGain, and it became, we open sourced it in Apache Software Foundation. So what I want to talk today about, it's kind of quick talk, and I want to kind of sort of a step back a little bit and talk about generally in memory computing, not related to GridGain or Ignite. Just generally talk about in memory computing and its sort of windy path to cloud. It wasn't a straightforward path for almost any vendor or any project, and there was some specific reasons for that. I mean, when you look from the outside, you have a sense that the memory computing vendors are kind of lost to sort of get on a bandwagon of a cloud-native application, cloud-native architecture. And you may wonder why, because in any other respect, in memory computing, generally viewed as kind of a cutting edge, you know, in sort of base, very academic, very sort of high-end use cases. And why all of a sudden that particular technology or that particular sector was, you know, sort of a laggard in terms of the cloud adoption. And I want to talk about some of the reasons in the past, and I will give you about 3 different trends that today really sort of speeding up this transition. And obviously, all of this is coming kind of from my viewpoint of view of being part of GridGain, part of Ignite community. So let's go ahead and talk about it. So what are the historical challenges? And this is probably one of the most important slides because it kind of gives you a perspective why it took literally a 2, 3 to maybe to 4 years longer than, you know, rest of the data processing, you know, ecosystem. So first of all, in memory computing is really, you know, in many ways counterintuitive to the cloud computing, at least the classical cloud computing. If you think about in memory computing, it's essentially scalable, low latency at high cost. So this is the trade-offs and benefits you get. You get a highly scalable or low latency applications. And low latency is very key here. But at high cost, you need to have RAM, and RAM typically is more expensive. You need to have essentially servers, computers, and you need to have them on a high-speed network. And essentially, you know, you trade up, you know, initial cost to low latency. And that equation was, you know, essentially true since, you know, late 90s when I started working in memory computing. It was always been an expensive proposition, but you get back this unattainable, low scalable latency that you cannot get with any other technology at a time. And when you think about cloud computing, it's almost the reverse. It's a scalable but high latency at low cost. At least, you know, what was cloud computing 5 to 10 years ago at the beginning, that was exactly that. It was fairly low cost because you're renting out, you pay as you go. But cloud computing was never about performance. It's a kind of, you know, it's a confusing point for many who kind of, you know, newcomers to this field that, you know, cloud computing was never about performance. It was about scale. So you can easily add and remove resources and be very, you know, economical about it. But the performance, latency, was never even, you know, considered to be any kind of advantage. As a matter of fact, even today, most cloud installations suffer from higher latencies. It's changing, and we'll talk about it, but even today, it's still an issue. So there was this kind of this mismatch in terms of the just a high level concept of a memory computing being an expensive proposition, but, you know, in return, you're getting this, you know, unimaginable low latency and magnificent performance in your use cases. And the cloud computing was almost reverse. You know, it was all about economy of scale, and latencies were orders of magnitude larger than you could get something on in-house installation. And then, over time, we all moved to sort of a hybrid installations, hybrid deployments, where part of your applications work on-premise, on in-house, and part of your applications work, in a cloud environment. We call it hybrid deployments, and that didn't help. So, as a matter of fact, I clearly remember when I was kind of working in this area number of years ago, I thought that's going to be sort of a breakthrough for memory computing. It didn't happen. It didn't happen because your system is slow as its slowest link. And obviously, this connection between the cloud and the in-house installation was always the slowest link, no matter what you do. You can layer out the VPN, you can layer out, a common network. It's still basically going to be a choking point for any type of communication. So hybrid deployment never really took off in terms of in-memory computing. It helped somewhat because people could have, had a dedicated clusters on cloud or on-premise that were very kind of walled off and dedicated, and that allowed them to have sort of an island of performance. But generally, it was a very haphazard deployment. It's hard to manage, and it's in my opinion, didn't really go far enough. Another problem, historical problem, was RAM. I'm talking about memory computing. Now, it's very important to understand that memory computing is not about memory only, right? Memory computing was always about memory first, disk second, versus traditional approach where you have disk first, memory second, right? In a traditional database systems, anything today that's not in memory based, your SQL databases, your Mongo, Couch, all of this, there are disk first, memory second, right? They use memory just as a temporary caching solution. Memory computing systems are completely different. They use RAM as a primary storage, and they use disk for overflow and a long-term durability. So the RAM was important, and RAM was 10, 20 years ago. I still remember, late 90s when, a gigabyte of RAM was a big deal and very expensive. So back then and today, 20 odd years later, RAM is still significantly more expensive than, your durable storage, whether it's a spinning disk, which practically nobody uses anymore, or even flash. Yet, flash is cheaper, but it's still, several orders of magnitude slower than, DDR5, DDR4. Even. Probably the biggest difference biggest obstacle, if you will, at least, from my perspective, from a GridGain perspective, was the kind of what I called impedance mismatch between the execution models. In the traditional database systems, and you take any SQL database, Mongo, Cassandra, Redis, both in-memory or traditional disk-based databases, they all work in what I usually call a client server or client request response protocol, right? You have your database somewhere. It doesn't really matter where it is. Could be local, could be in the cloud. You send a request, you get a response back. That's sort of a typical model that's been there for half a century. And this model is very easy to cloud enabled, as you can probably sense, right? As I mentioned at the beginning, it doesn't really matter where your server is or where your cluster is. You send a request, get a response. That's your entire API to database. In memory computing, that's different. And that's where I think a lot of folks kind of are missing the point of a challenge. The big part of the memory computing is in process execution, right? This is the RAM. So to execute something on a RAM, you have to have something in the same process space, ideally. To have something in the same process space, you have to deploy user code on the cloud. And that's basically a massive step function in complexity. It's one thing to have a very basic request response protocol. Anybody can do it in a free time. It's a completely different endeavor to have a code deployment, code version, code security, code redeployment, and all of that, wrapped up in sort of an enterprise dressing that, people can actually use it in a series, use cases. And for us at GridGain, that was probably one of the biggest challenges that we've tried to dance around about different ways of kind of, sort of a cutting back on functionality and just do the request response like everybody else does. And it never worked for us. We could never find a happy medium and, sort of a happy product definition, if you will. And it took us, literally a couple of extra years versus the sort of the rest of the industry to really come up with a safe and a proper way to deploy and manage user code in the cloud, so we can get the benefits of in-memory computing. It's a very important point. Again, whenever you think about cloud enablement, keep in mind that there is a significant mismatch, or essentially difference, between execution model, how people use traditional databases that are based on just the request response protocol and memory computing, that more often than not require to deploy your code. If you want to run your computations the most effective way, you have to deploy your computations on the same cluster where your code is going to be running. And that is a very different set of problems. So that's basically a historical kind of context, right? That's why you would see many memory computing vendors and projects seemingly slow to adapt to cloud computing. Obviously, it's not for the reasons that we're just not aware of it or we're not understanding the importance of that. We obviously do. All of us do. At this point in time, it's hard not to. But there were some, objective challenges on this process. So let me talk about some of the trends that are rapidly changing in this context, and that's some of them will be somewhat obvious, but most of them will be in the context of those challenges as I described. So trend number one is really, obviously maturity of cloud, what I call cloud native infrastructure. That's this. If you look at this slide, like in a 10-year perspective, you can easily see why. You just look at all these topics and think about them 10 years back, and you will clearly understand sort of a progressions we all made in terms of the cloud enablement. So today we have a broad availability of what I call in-memory friendly infrastructure on the major vendors, from Amazon to Azure to Google to IBM to Oracle to Fujitsu Clouds. I mean, practically anywhere you go, you can find a memory-intensive instances that are priced correctly, multi-CPU high-core instances that are also important for a lot of memory use cases. Even GPU instances becoming available. Something that GridGain is about to release in terms of the next iteration of our infrastructure platform. So there's a broad availability of something that 7 years ago you should have actually you had to buy and deploy somewhere in your premises or in your private data center to actually have. Today, those things are becoming available on the cloud. High-speed in cloud networking, it's a pretty big deal too. I mean, again, without high-speed networking, having a large cluster of memory computing or even hybrid deployments are becoming, pretty much useless. And today we do have that. We have high-performance cloud VPN. Again, this is the area that helps dramatically in terms of the offloading the in-memory computing cases onto the cloud. We have the whole, kind of, cloud in the box, initiatives from, Amazon Outposts to SDDC, software-defined data centers, all of them helping sort of moving in the same direction. If you want to have benefits of a cloud, but you don't want to lose the performance advantages of sort of a low latency kind of on-premise installation, we now have more options. Probably one of the most important, point here is just a basic maturity of the foundational stack. Your Kubernetes, your Docker, your OpenShift, and OpenStack, all these technologies, some of them actually were not even available 10 years ago. And today, they're literally your operating system on the cloud. And that's a massive step forward because you don't have to deal with everything this Kubernetes and Docker does today. It gives you a tremendous amount of automation and really helps out move some of those complex memory computing use cases or scenarios or applications on the cloud. And all of that essentially makes enterprise apps more open to run fully on the cloud infrastructure versus on-premise or hybrid. And again, this is something that even I think that Steven also mentioned, that even now from GridGain perspective, we're looking at 3 to 4 years ago, we had a lot more customers who will come into us and say, look, we're not going to touch the cloud. We're trying to use a memory computing for speed. Why do we have to go to cloud? Because we're going to lose all of it. And it was true. That was actually true. Especially for kind of a bigger customers, for its more complex applications. And it's rapidly becoming a much, much less of an issue. And I truly believe that, and we'll talk about my third trend. Remember this third slide. When you combine that with the third slide, which is pretty exciting, I believe that the next decade, let's say we talk 10 years from now, I think it's going to be very hard to find a company who would actually have that mentality that, hey, we're not going to go to the cloud. Today, still, maybe I would say 20% of the companies in this group. In 10 years from now, I think we're going to be fully on the cloud. So the next trend, the second one, is pretty obvious too. New storage and new compute planes. That is a pretty big deal as well. Predominantly about memory, because obviously memory computing is about memory. And today we have a plethora of new types of RAM. Probably the most popular one that's everybody's talking is Intel Optane, and Intel is making a pretty big bet on this. It's becoming available on the cloud infrastructure. We now have operating systems supporting that in some way, shape, or form. So that's a pretty big deal, because again, 5-10 years ago, any of this, and GridGain was at the very, very beginning of the non-volatile memory kind of movement. We work with Micron, we work with Intel, years and years ago. And back in those days, forget about clouds. If you want to use any of this new stuff, it's all about on-prem. And for many customers, that was a sort of a almost like a barrier, right? If they want to use some of the new memory stuff, clouds are not even an option. Just technically, you can never get this stuff anywhere in the cloud. It's changing rapidly. Intel Optane is available at least on AWS, as far as I know, and I think Azure as well. And I think we're going to see more and more different types of RAM becoming rapidly available on the cloud, and it's a great thing. For example, Intel Optane is has a bioaddressable mode, so it can truly be acting as a non-volatile RAM. There's a different type of issues. How do you program it to it? What are the use cases? All of this complexity is still there, but at least from a sort of availability standpoint, it's there, and you can take advantage of that. And I do believe that it's gonna improve going forward. Another interesting thing is that we're finally sort of maturing for a GPU-based processing away from just the games and the cryptocurrencies and the machine learning. Those were niche use cases for GPUs for years and years, and I think the GPU compute plane is becoming sort of a equal partner in terms of the computing processing on a modern infrastructure. GridGain is working very actively in this area. We're going to be soon releasing fairly fantastic technology that allows it to run on the GPUs as well as on just the prime CPU. And we would not be investing in this area if cloud vendors wouldn't be ready for this. We kind of learned our lessons with non-volatile RAM. We were very early into the game and sort of suffered this long transition. And today, GPUs based on GPU optimized, the GPU available instances available almost everywhere. It's going to be, in my opinion, one of the driving forces. This and my next point is about vectorized execution. Those two new compute planes is going to be the big deal in the next 10 years. And the projects and vendors that can take advantage of this new computing planes will see huge benefits. Let me just remind you, for the people not familiar with, GPU, for example, has thousands of cores. So not every task can execute properly in GPU, right? It's not every task can do this, because it's just a architectural execution, but just the brute force capability of that compute plane is enormous. It has DDR5 as a storage versus DDR4 that most of our servers have today. That's a significant step up in performance, plus 1,000 cores. I mean, how many cores do you have on your computer, right, on your cluster? And a single GPU core can have thousands of cores. So it's a huge deal if you can take advantage of that. And again, in the past, you could have, but you will always relegate it to the on-premise installation, like basically a non-cloud. And today, it's all becoming part of the cloud native story, which obviously plays a big role, or plays a big important role in for memory computing. And the same can be said about vectorized execution. It's one of those areas that for data processing folks is considered to be kind of unknown, but still it's available on the high-end CPUs from Intel and AMD in different shape or form. But that's basically a parallel processing right there in CPU without a need to move the data content from one memory to another. So the new storage, new compute planes is either becoming available or already available on a cloud, and that's a massive trend. So again, it removes yet another reason to stay on-prem, and you can actually move to the cloud. The last, it's actually the last slide I have. I'm running a little bit of a time, but probably the most exciting one is there really sort of an emergence of what I would call kind of the next iteration of edge computing, or what sometimes people call, or not sometimes, but now there's a terminology for that. It's called extensible public internet. This is the proposal actually that's sort of in a mid stage right now. It's basically almost every major company is behind it, from Microsoft to Oracle to Google to Amazon and whatnot. There's a link, by the way. You guys can look at my slide. There's a link in the bottom to read this. This is a big deal, in my opinion. There's a fundamental problem with a cloud applications, and if you want to move entirely to the cloud infrastructure, right? We still have very strange sort of a IP address based communication paradigm, and for example, for a true content on the internet, there's a CDN-like approach, right, where a content is distributed everywhere, and when you download your videos, imagery, it all comes from a local installation, so it's much quicker, much faster, and whatnot. So the same things is kind of the same idea is being proposed for actual applications. So essentially, kind of CDN-like model for applications, and that's basically fix one of the major problems with the edge computing and in memory computing. As part of that, is this movement is that thing is really local. If you imagine your applications on a smartphone, right? When you're moving, when you're driving the smartphone, you're constantly switching, networks where you're joining in, right? Different towers, different network, and your state has to follow you. And today, it's actually, a memory computing is used a lot in this application, especially in 5G applications, but it's a cumbersome in many ways. And still, many vendors still tend to kind of, push back on a kind of full cloud deployment and trying to sort of, work in an older model, right? But as the more we move in this new type of applications that are truly native to the cloud, that live only on the cloud, they live on this edge computing sort of a current paradigm, where you execute certain things on the edge or internet, right, close to you, but not entirely on premise, but kind of in the middle between you and the cloud. To make this happen, we have to have this new proposal. And a number of years ago, I would say, well, this is basically lots of hot talk, and who knows how it's going to be. But we have major companies backing this, and the time is now. Because this proposal is really addressing a lot of fundamental systemic issues we have in the current internet, and it was never designed for applications. When you think back, it was never designed for this. And the memory computing, by the way, is would be one of the greatest benefactor of that move, because it will essentially free up or remove all of those little and not so little obstacles for getting this high highly scalable, low latency applications right on the cloud without any obstacles from the underlying architecture. So I'm going to stop here. I want to thank you again for joining us. I hope I gave you a nice quick overview of why it took longer for in-memory computing systems or projects or vendors. What are some of the key trends going forward? And why I believe that's, this is another that I don't believe the cloud will, accelerate. Cloud will accelerate, but why memory computing will actually catch up and have, a good shot to become one of the top technology on the cloud. So with that, thank you very much.
Thanks, Nikita. That was fascinating. So we're running slightly over, so we won't have any questions for this time. Maybe if you can add them in the chat, we can kind of come back to it kind of later on. But otherwise, thank you for your time and your talk, Nikita. That was great.